Cool, cool. All right. Well, glad we were able to connect and after, definitely some exciting years of development and improvement on Zcash protocol, as well as the integration side of Edge. You've got great 2.0 SDK that just kind of launched a couple weeks ago,
Oh
right?
yeah.
So I think goal here is that let's give people an idea of what exactly this thing entailed, like what went into this effort and what should people expect to be able to experience, or hopefully just not really know what's going on and just things just get magically better, under the covers.
Yeah. That's
That's
the best user experience is when the user doesn't realize all the engineering that's happening.
exactly, we hide it
Just does
from
what
them.
they assumed it would do.
Yep. And so obviously want to make this a community kind of focused space. So if people do have questions, feel free to raise your hand. We'll
Yeah.
happily answer them. If they have comments, questions, want to chime in on anything, we'll try to keep this open for the community. But we'll kind of dive right into it because I know we had a few technical hurdles and we got, limited time. Everyone's got stuff to do. So maybe you want to give us a quick update. I know you focused a lot in the marketing, not only call it marketing, but outreach to the community about this 2.0 update and really hovering around spend before sync.
Yeah.
Right? That
Spin
seemed to be
before
almost
sync.
like the title. If you had to put a title to this movie of SDK 2.0,
Yeah.
maybe kind of give us a little idea of what that is and why it's a feature versus what people might be accustomed to in other assets.
Yeah, that's a good question. It's definitely one of those things that when it works, it's just what you assumed it ought to have done all along, which is that when you use your wallet and you open your wallet and you have money in your wallet and you want to spend it, you can spend it. That's all. It's
It's kind of what you
and
expect,
then
right?
and then what that's replacing is the previous state of the art where you would open your wallet and then you couldn't spend your money until your wallet did this thing called syncing.
Hmm, got it.
And it was an
And
amazing amount of engineering under the hood just to eliminate that unnecessary delay.
so I know we talked about this almost a year ago, if not a little bit over a year ago, on enabling spend before sync. And I'll go into what hopefully is not too technical for people that are listening here today, but Zcash, unlike Ethereum and other chains, it's closer to Bitcoin, right? It was kind of patterned after Bitcoin.
Yep.
And with Bitcoin, you receive what I like to um, make as analogy, basically bills into your cash register, right? They just happen to be arbitrary denomination bills, but then you
Right.
spend one of those bills every time you want to spend money. And sometimes it might not be the amount that you want to spend, and so you get change. That's like what we call like the UTXO based currencies.
Mm-hmm.
Um, and with most Bitcoin or Bitcoin like wallets and apps, it's true. You don't have to wait for additional sync. Once you've synced what you have, this bill is in your register. I should be able to spend the bill in the register, even if I don't know of other bills that are coming in, right?
Yeah,
What
exactly.
what makes this harder in a privacy coin like Zcash? What made it tougher to do, and
Yeah,
hence the engineering involved?
that's a good question. The privacy is the key thing that makes it harder. And by the way, the Bitcoin was the first, and it did this what you call UTXO model, what everyone calls the UTXO model, where you have these
Mhm.
bills that you have to shuffle back and forth. And then when Ethereum came along, Vitalik threw out the UTXO model and made an account model where you just have an entry that says how much you have and you can add or subtract from that entry. And I was just recently talking to Vitalik about how they are now revisiting the UTXO model because it has some advantages in terms of privacy and scalability. The
Oh,
account
of
model.
course.
So with the account model, the problem is there's this one entry, and every time you want to touch it, you have to touch the same
The
memory
same entry, the same
location.
state,
Yeah, the same
right?
state. So that means you have to propagate that state
Lock everyone.
everywhere. And yeah, so it's got a lot of scalability and privacy drawbacks, actually, even though it has also a lot of usability advantages for the account model.
Yep.
But anyway, we're over here in the UTXO model, and when you try to add privacy to it, then that's what introduces the user experience problems. So Bitcoin introduced the UTXO model, and they had some hopium that Bitcoin would have privacy, but it actually has no privacy at all. And when we took the Bitcoin architecture and made Zcash, we added privacy, but to prevent, so let's see, there's like a server that your mobile phone is going to connect to send and receive your transactions. Because you don't want to run a Bitcoin full node or a Zcash full node on your mobile phone because it takes like hundreds of gigabytes of storage and it downloads the blockchain all day, every day, and so forth. So that's a non-starter. So you got to have a server that you connect to. That the server is part of the full node network, and then your mobile phone talks to that server to get your specific transactions. And for privacy, there's this fundamental trade-off between what the server finds out about your mobile phone and how much work your mobile phone has to do. So at the one extreme, you could just tell the server all of your secrets. You could tell it your address and your identity, and then it could just send you all the transactions that are yours, but then it would know what transactions are yours. And at the other extreme, you could download all the transactions that happen on the whole network from that server to your mobile phone, and then you could pick out the ones that are to you out of that. And what we have now in Zcash is like a compromise between those. It still errs pretty far on the side of privacy, so it downloads basically all the transactions that happen on the Zcash network, so that the server can't tell which ones are for you. Okay?
That's what's happening right now in most mobile apps using the SDK from ECC.
It is, yeah. There's some optimizations to reduce how much bandwidth your phone has to download and how much CPU and how long it takes.
And that's the compact blocks concept, right?
Yeah, most of those optimizations is the compact blocks concept, but it still errs pretty far on the side of privacy to where it reveals as little as it can to the server about which transactions are yours. So in this trade-off between usability and performance versus privacy, it's like there's no perfect solution. There's only trade-offs. And the current Zcash protocol, the light client protocol and the compact blocks protocol, is a forefront of a good trade-off between getting really good privacy and also good usability. You know what I'm saying?
So that's from the viewpoint of detecting transactions. And I know I've gotten into a lot of conversations with kind of privacy advocates and chains and shared that kind of concern where it really is just that trade-off. But once you've detected your transactions, and this is we're getting back to the spend before sync, once you've detected their transactions and you know they're yours and you have those UTXOs sitting in your cash register, what's been the challenge in allowing someone to then send that, even if they don't know anything about maybe 100 blocks in the future that have nothing to do with them?
Exactly. That's the right technical question. And the answer is that when you spend Zcash, you prove that it's a valid note. Like the bank note that you have in your cash register, you want to give it to someone else, and you include with it a proof to them that this is a valid note that's never been spent before by you or anyone. It hasn't been counterfeited out of thin air. It's one of the 21 million special valid Zcash notes, right? But you want to prove that to them without revealing to them anything about your identity or the note's history.
Okay.
So that's the magic of the zero knowledge proof approach to cryptocurrency privacy, is that zero knowledge proof. So what you're proving to them is that this is one of the valid notes that is out there circulating, but you're not giving them any information about which one.
Got it.
Well, you got to get more new information from the blockchain in order to prove that yours is one of the notes that's currently circulating. You could show them a proof that it was one of the valid notes that was circulating when you received it and put it in your cash register. But that would reveal to the recipient that it's that old, like it's been 6 months or something. They can tell that this note hasn't been used in 6 months. And we're pretty obsessive about privacy at the Electric Coin Company. The Zcash protocol at the blockchain level and also at this light client level is already the best privacy that you can get with a actual live protocol today. But we also wanted to reduce the leakage to the recipient about the information about how old your node is. Does that make sense?
Yeah, it does. And so this
Yeah.
proof effectively, by only knowing, say, 500 blocks ago from
Right.
present, when you create that proof, it now is not able to include possibly in the mixing of other UTXOs that are more current. Is that kind of the issue? Does that summarize?
Exactly. So now what we've done with SDK 2.0 is it gets just enough information from the blockchain to prove that your node is one of all of the valid nodes ever up until today.
Current.
Yeah.
Got it. So it's spend before full sync, but it does require a tiny bit. Is it basically like latest block type of information? Or what does it really need?
It has to get a little bit of information from several of the blocks. I don't remember the precise amount of information, but it's a little bit of information from several of the blocks between whenever you got that note 6 months ago and the most recent block. And it's such a little bit of information that your mobile phone using the ECC SDK 2.0 can download it in like a few seconds, like 5 seconds or something like that.
Got it. It's fast enough that people don't even notice it.
Yeah, you don't even notice it. And then that's enough information to provide this proof, which gives you the maximum privacy on your node. You can now prove that your node is one of all of the valid nodes ever. You could have gotten it an hour ago. You could have gotten it a year ago. And there's no information available to the recipient about anything about where it came from or anything about you.
Got it. And I want to put a caveat to spend before sync, which applies to Zcash, but also applies to Bitcoin. There's somewhat of this assumption that your cash register only exists on one device. In the sense that if you were to have your keys on 2 different devices, your cash register kind of exists on 2 devices now. And if you were to spend on one device, it may not be possible to spend on another one until that one synchronizes. Correct me if I'm wrong on this one.
Oh, absolutely. That's one of the remaining UX challenges that the whole cryptocurrency industry, but especially Edge and ECC have to tackle. Because it turns out users like cryptographers like me have never cloned the same seed into 2 different wallets and then tried to use both of them. You know what I'm saying? Like I only reuse the seed if I'm abandoning the old wallet and importing everything into the new wallet, then I'm only going to use the new wallet. So just like you say, that's like you've got a new cash register, you have a copy of all the bills from the old one. And now you just never open the old one again, and now you can spin the bills out of the new one, no problem. But if you copy the cash register and you have copies of all the bills in there and you spend one out of the one, later, if you go to spend out of the other one and you use the same bill that you already spent, the Zcash protocol is going to correctly prevent that bill from being valid because that's a double spend, right? And you've been trying to use the same bill twice, and it's not going to work. But therefore, the result is today, if somebody imports their backup seed into like 2 different phones, if you install Edge on 2 different phones, and instead of using the same Edge account, I'm not sure how Edge handles.
Actually, if you just simply use the same Edge account, that would synchronize the seed across 2 devices.
Okay.
And so therefore, you would need to have the second device fully sync, I presume, to know that some of the money is spent before you could spend whatever's remaining.
So then if you go to spend before sync, you'll get some kind of error message. It'll say you can't spend that, because your phone, your Edge wallet doesn't know that the other phone has already spent the money, right? So it assumes it's valid. So it goes to send it to the recipient. And then the Zcash network says that transaction is invalid.
Got it. Yep.
So you get an error.
Now, I'm going to go into a little bit of a nuanced detail because someone might actually run into this and say, wait, I think Zuko and Paul are wrong, which is, at least in Bitcoin, correct me if I'm wrong, I don't know if Zcash is the same way, but in Bitcoin, when you spend, you're spending specific bills out of your register.
Yeah.
And even if you have 2 devices, there's a chance that the second device, even though it's not synced, might spend different bills.
Yeah. Then it would work.
Is that actually going to work also in Zcash, or is due to the privacy that wouldn't work? Okay, so that actually could work in Zcash.
Yeah, so you could get lucky and
you get lucky.
one bill out of one register and a different bill out of the other register. They both work. And to what you said, once it syncs, then your wallet finds out that those bills have already been spent. So then it knows not to try to spend them again. So then,
got it. So that's like the little note to those listening. Yes, there is a potentially you get lucky case where you are able to spend out of two devices, but don't rely on it. It easily could, potentially not work. So
Yeah. So basically,
it's
like if you only ever have one wallet with a certain seed, if you only ever use one wallet with your seed, then the functionality should be 100% reliable. Like every time you go to spend, it'll work.
It just work.
Fast and reliable and all that. And then the thing that I don't like is if people are doing this thing, which turns out to be quite common, apparently, in practice, where they have the same seed in multiple phones and then they use one and then they go use the other one, then you'll sometimes get failures. And that's
that can happen.
That's not good enough. We must have zero failures.
Yeah, I'm guilty of that. I mean, I've got a tablet and I've got a phone. It's convenient sometimes for me to use my tablet, when spending, and so therefore, yes, I would be a person that would have to wait for full sync before I can spend any Zcash on both. But it's not common that I use both, and so I have to just make a note of it. And you're right, it's a user experience thing that people aren't used to, especially if you're just in legacy banking, because it's all fully centralized. There's no sync period.
Yeah.
And we'll talk about like the potential for a no sync architecture at the end of this, because I think that's something that's pretty exciting. We've talked about it quite a bit. But let's first continue on with SDK 2.0. Some other things that went in are, even without the spend before sync on its own was kind of slow. And I know that there were some optimizations that went in there. We had a little breakfast and you talked about them, and I remember going, aha, that makes sense. Although admittedly, they were fairly nuanced, that they're not top of mind for me anymore. Maybe you can recap some of the optimizations that have gone in.
I don't remember how my engineers did those optimizations. A big part of it is always just parallelizing computation, because your modern CPU in your phone can do like 1,000 things at once. But typically, if you don't optimize for this, then it'll just do one thing at a time. That'll take way longer.
Yeah, right. Would you say then that a lot of it
parallelization?
So in the parallelization, that's like the computing that's happening on the device. So would you say that most of the limitations have been not bandwidth related, but more compute related on the device?
I mean, there have been both kinds of limitations in performance, but in my view, the biggest one, like, I'm really proud about spend before sync because I think it was kind of a conceptual leap. Like when we started, what everyone's pain point was when using Zcash was sync is too slow, right? So you'd open your Zcash wallet on your phone. You're standing in line at the coffee shop, which I do like literally every day, and I buy my coffee with Zcash. And back, in the bad old days, you'd open your phone and you'd be like, oh shit, I didn't sync. It's going to take like 3 minutes or 10 minutes or something, and the people behind me are going to be really pissed. So now what do I do? Right? And so from that perspective, as a performance problem, the solution is make it sync faster, right? And ECC and several other teams on the Zcash ecosystem made good progress on that. We made it sync faster. But that's actually not good enough, right? Because then if you haven't opened your phone for a month, then no matter how fast it goes, it's still going to take like 5 minutes or whatever to sync, and the people in line behind you are still going to be pissed. It's still going to be annoying. So that's why I'm really pleased with spend before sync, even though it took a lot of time and engineering to implement it. But now it actually works, including an edge. And what that means is the people behind you in line are not pissed, and you are not annoyed. So I think there's kind of a lesson among within engineering is you've got a problem, it takes too long, you could make it go shorter, that would be great. But if you can make it take zero time, and you just like don't do that thing, that's the best possible optimization.
Got it. Okay, and it's interesting because it's a zero time because you've identified the specific case where people are hitting this issue, which is, hey, I need to actually send money right now.
Exactly. Now, that's the process by which we came up with the concept of spend before sync at ECC. And by the way, probably other teams within Zcash have already come up with the same thing or implemented the same thing. So I'm not claiming novelty or credit. But our process was like looking at the user pain points, the user experience complaints and problems that we have and that users tell us they have. And then realizing, oh, there's two different use cases here. One is you've opened your phone and you're waiting for someone to pay you. right? Like they told you that they paid you and you're waiting for it to show up. And then the other use case is you already had money in your phone. You open your phone and you want to spend it. And so the realization is that we can solve the second one.
Right.
We can reduce the wait time to like 0 or 2 seconds or whatever.
But we're not necessarily solving the first
case.
one.
No, it doesn't solve the first
although,
case.
Although the optimizations overall do improve, I believe that second case. So they improve it, but they haven't what you'd call like really solve it.
Yeah, you know? But as far as I know, I've never really experienced. Maybe I have. I don't remember experiencing like frustration where I want to make sure that somebody paid me, and I'm waiting for my wallet to sync so I can find out if they paid me. That's not very common, at least for me, and I don't remember a lot of other people complaining about that.
Got it.
Maybe that'll be another problem we'll need to solve in the future.
Yeah, it's definitely one that people can run into. I know I've ran into it with SDK 1.0 because at times if I just simply don't open my wallet for a really long time, right, the sync could take a while. It could take hours, could take days. And if someone sends me money, I just won't see it. So for sure, I've ran into it. But it's been a notable subset of the complaints versus the spending. The spending is like the low-hanging fruit, right? Let's go ahead and solve that. And I think you guys, obviously focused on that and got that one knocked out and out the door. So very cool. Spend before sync. There are some sync perfs. We don't have the exact details. I know there was something about like out of order block syncing, like something along those lines, but I didn't fully understand that helped with the performance.
Yeah, I don't really know.
And if it skips your mind, maybe we'll have a tech guy on here to explain some of these nuanced things.
Get one of our engineers to join.
Yeah. Okay, cool. So another thing that I know wasn't necessarily specifically part of SDK 2.0, or maybe it was because I'm not one of the developers that implemented the SDK into Edge, was unified addresses. And this is where Edge started supporting unified addresses. And for people that don't know, maybe you can give a little update, or not an update, but pretty much a recap of what they are in the first place. We were in Edge, being kind of the, privacy Nazis, similar to ECC, extreme. So I know way back when we started talking back in like 2016, 17 or 18, I was like, no, I don't want to do ZCash T addresses. Right? And I gave you a hard time about it. I'm like, until I know that there is a good roadmap for usable Z addresses, then we'll stay away for now. And you guys delivered on that roadmap. And when we shipped Zcash support, it was Z address only, and that's it. But unified addresses and something that we implemented called auto shielding really kind of hit the mark on flexibility of transparent and Z addresses. But what exactly are unified addresses? You can kind of cover that.
Oh yeah. Thanks for asking. This is something else that I'm really proud of. I think unified addresses are great, and I eventually think that the whole rest of the cryptocurrency world, like Ethereum and Bitcoin, are going to have to adopt or reinvent the same thing, even. So we started with T addresses and Z addresses, and sure enough, Edge, with strong principles or whatever, chose a very specific trade-off and deployed Z addresses only and no T addresses. And there's the intention, I believe, was to maximize privacy. But it's kind of complicated to analyze what kind of privacy you actually get in practice from different usages. So maybe we can get into that now that you have this upgrade. But one UX trade-off with that is then with the previous version of Edge, I couldn't withdraw from Coinbase into Edge Wallet. Right? Because Coinbase only sends to T addresses, and Edge Wallet didn't have a T address. So, and we have that same problem throughout the ecosystem. Like we had two different types of addresses. So there's two problems. One is incompatibility. Like the Coinbase versus Edge example is a great example. Now, if you have some ZEC in Coinbase and you want to get it into the old previous version of Edge, what you've got to do is get a third wallet that speaks both languages, withdraw from Coinbase into that wallet, and then send from that wallet to Edge. So that's a huge problem. And then the other problem that I really thought about a lot, because I really like to focus on user experience and to be kind of obsessive. I said we're obsessive about privacy, but we're also obsessive about user experience. And I like to be really sensitive that what we call UX paper cuts are things that experienced people and crypto nerds are so familiar with, they don't even realize that they're working around it every time. But then if you give the same thing to someone who's inexperienced or not a nerd and just wants to do a thing, that paper cut will really interfere with their life or prevent them from even succeeding at their goal. And back when we had two different types of addresses, you had that problem that someone would say, will you send me Zcash for that? And they'll say, yeah, sure. They'll say, okay, send me your address. And they'll send the address. And then they'll try it and it doesn't work. It's the wrong kind of address.
Note that Bitcoin has had this problem pretty much since, I mean, I'd like to say since SegWit, although it predates that a little bit with multi-sig P2SH addresses that start with a 3. And it's one of those, every time a new address is implemented, there now is this incompatibility problem across multiple implementations, wallets, exchanges. And Bitcoin is probably the shining example of death by a million paper cuts, at least with address support. Because they've got, I can't count how many address formats there are now. And how many times we've had to update the app to support this new address, both sending and receiving, which are two different efforts.
And for
I just want to make sure people are aware that it's not just.
Nerds enjoy them. That was cute. For nerds, it's no problem. And in fact, I think nerds actually enjoy it, right? They're like, oh, no, you sent me a P2SH, but I need a SegWit. And they're like, oh, my bad, I'll give you a SegWit.
I'd like to think I'm a nerd, and I absolutely dislike it. I absolutely hate it.
I'm getting less and less tolerant of that. But for normal people, I think what typically happens in a case like that, it's like, send me your address. Okay, here's my address. I'll send you the coins. And then their wallet or their crypto exchange or whatever, it just gives them an incomprehensible error message, right? It's like error code 13 wrong, right? And then what normal people do, they just give up. They're like, why don't you Venmo me instead, right? So unified addresses was our attempt to solve this. And it came out when we invented the Orchard upgrade, which is the latest and greatest ZCash shielded protocol. Because we had already had T addresses and Z addresses. We actually had two different versions of Z addresses, but the old one was so old that no one used it anymore, so it wasn't a problem. But we had 2 or 3 different address types, depending on how you count, and we're coming up with a new address type. And then we realized, oh my God, if we add a 3rd/4th address type, it's just going to get worse. There's going to be even more like exchanges and wallets that can't talk to each other, and even more people asking to send and then it not working. They get an error message and they give up. So we came up with a unified address, which is just a QR code or a real long string. And inside of it, where the user can't see, we've hidden both a T address and a Z address, and other, like all the addresses are packed in there. Got it. Edge has now deployed that. And now if you scan the Edge QR code or send the Edge address, then your sending wallet, if it will parse the U address, it can send to either the T address or the Z address.
Which is something that needs a little bit of adoption.
Right. So this is the point. Now we've like brought the bridge this far. There's one last plank that we need in the bridge so that users can just use it and it'll just work without incomprehensible error codes. And that's on Coinbase. So everyone send a polite support request to Coinbase right now. Like, dear Coinbase, I'm trying to withdraw to my Edge wallet. Edge supports everything it needs to support, but you have not yet upgraded.
Right.
That's all they need to do.
And I know the parsing of the address, and for those that are technical out there, it's not a difficult technical thing.
It's like 5 lines of whatever scripting language they use at Coinbase. It's like 5 lines. All they have to do is take the U address and read the T address out of it, and then do everything that they normally do. So it doesn't change anything about Coinbase's operations. It doesn't change anything about their security. It doesn't change anything about their regulatory stance. It doesn't change anything for them. They just need to upgrade to support the UX standard so that people stop having paper cuts. So everyone write to Coinbase right now. Thank you.
Now, we actually work with a handful of swap exchanges that also don't support the unified address. Is that little 5 lines of code, is that available as a snippet of language code in different languages that we could just send over to them and say, hey, here's a little library? Because I know that for us to do it, we have to go all the way into like Rust code and back. Which isn't convenient for people that are just running.
Right. It should be. There should be like a little parser snippet that you basically cut and paste into your exchange.
JavaScript, probably,
Python. Yeah, every language could do it. I'm not aware of a library of that. There's this guy, Andrew Arnott, the ZCash hacker, who
Mhm.
spent quite a long time learning everything there is to learn about ZCash addresses and stuff, because he's implementing it for .NET. And I think he's basically succeeded at implementing
Wow,
.NET. But someone
interesting.
like Andrew could write that little parser, which is a stateless thing. Like the parser doesn't get
Yeah, no, it's
access
not
to your database. It doesn't get
keys or
access to
nothing.
your keys. All it does is it takes in the the unified address, and then it spits out the T
Spits
address.
out the other. We'd love to be able to have one of those, actually.
Yeah, someone should write
So,
that.
all right, someone please take
How about
advantage.
Andrew
Become
Arnott?
an open source contributor. You can become like little 15 seconds of fame for writing the parser.
And then I could withdraw from Coinbase to my Edge wallet directly.
Yeah, that would be great. Okay,
And
cool.
about auto shielding. That's where I said
Yeah.
it's really complicated to analyze the privacy properties you get from T addresses,
Mhm.
or from a mixture of different address types used on different
Right.
wallets and so forth. There's a simplistic idea that like T addresses are privacy kryptonite, and if you use one, you lose your privacy. But that's not exactly true in most cases. And what the current Edge does is a great example. There is a T address hidden inside the Edge the Edge Unified Address.
Right.
And I did this yesterday for an experiment. I sent to the T address. I sent from a wallet that would only send a T address into Edge.
Mhm.
And then what Edge did was automatically shielded that money. So
Right.
if you're looking at it in a block explorer, you see like transparent address transactions are visible on a block explorer, just like Bitcoin transactions, right? So you see the money went from here to here to here to here to a block explorer, and then it went from here to my Edge wallet's T address, and then it disappeared, right?
Right.
Just
Exactly.
disappeared from the public view.
Right.
And that happens automatically now in Edge. So that's another really great upgrade.
Yeah, it's something that we kind of analyzed ago and said, okay, well, what's the privacy implication? That's the thing that you were saying, like, okay, where is it kryptonite to be using a T address? Where is it not? And if we had implemented T addresses without auto shielding, what we would find is that there would be notable transparent address funds held for a duration of time. I think that's the key thing, is holding funds for a duration of time allows you to associate that this incoming funds were yours, and then that outgoing transaction
Exactly.
is something that you as well did, and that could have gone spent to somebody else. So, but
Mhm.
by making sure that guaranteed you're not sending a transparent address out to another transparent address that could be someone else's, and not having a time correlation to when
Right.
someone receives funds, then all you ever see is an immediate, as soon as a T address receives some funds, it immediately gets shielded
Yeah.
and rotated as well. It's actually a new T address
Yeah.
that comes around. So there's no T address that should receive funds more than once unless someone reuses the fact that they're reusing that unified address that you had shared.
If you like screenshotted your QR code and you gave it to multiple people and they all
Right.
sent to it, then that
To the
might
T
be
address, right?
right.
That would be
Right.
the issue.
No,
So
that's a really good move on Edge's part. So that thing that I did yesterday, you're exactly right about the timing. Somebody can look on Arkham Intelligence Visualizer or Chainalysis or whatever, and they can see this sequence of publicly visible, transparent Zcash transactions, which then terminated, right? It went into the shielded pool yesterday. That's the money that I sent to my Edge wallet yesterday. And now if I go to my Edge wallet right now and send some of those funds to someone, then there's not going to be any link, even if I send to a T address, right? Because now it's sitting in the shielded pool. So if I donate to like the EFF's T address or something today, then there's going to be some money that appears out of the shielded pool and goes to the EFF's T address. But since it's just been sitting there and the timing and the amount that's stored in my Edge wallet is not known to Chainalysis or Arkham or whatever, there's no ability, there's no way to
association.
There's no way to link the past and the future. So like, this is something that I'm trying to figure out how to communicate better. Is a wallet like Edge, it's auto shielding your funds and then you're holding them there and then time's passing and then you choose to do something later. That's sort of like that's the thing that breaks the links in Chainalysis.
Right.
There's no more ability to link after that.
not trying to step into toes of.
So
Right.
this is a case
And this
where
is a key thing. Time is a
privacy
piece.
poison. Like if I send to EFF's address, that's privacy poison or that's transparency for EFF. Maybe they want people to know what their donations are, or maybe they don't, or whatever. But since I'm sending from my Edge wallet, which does auto shielding, it has no effect on my privacy for me to send to EFF's address.
And I want to make sure that we're also, quote unquote, transparent about the user experience of that. You ran into some of the user experience issues, which, are things that we can improve over time. But because we're doing auto shielding for privacy's sake, it's not going to feel as standard as receiving directly into a Z address. So number one, as soon as you receive into the T address portion of your unified address in Edge has to then create a transaction to shield that money. And number one, the creation of that transaction costs a little bit of ZEC, right? Yeah. Fortunately, ZEC is super cheap. It doesn't cost a whole lot.
It costs 50 microzecs or so. 100 microzecs. So
almost nothing.
0.0001 ZEC. So it's like 0.01 cents or something like that.
Exactly. So basically unnoticeable. It's really cheap. That isn't much of a user experience issue. You just have to be aware that it is happening. But the second thing is, because we don't want you to spend out of the transparent address, and that becomes a huge privacy leak, we don't let those funds get spent until they're shielded. And we do have some UX UI changes to make to improve on this. But if you try to spend those funds, then it'll become an error, insufficient funds available, because we're only trying to spend out of the transparent pool in your wallet. So be aware of that can happen. You receive money, you see your balance go up, and currently we don't show what's kind of locked and what's not locked in Edge. And so therefore you might try to spend that whole amount, and then boom, error, ugly error. And so
at ECC, we're working on a new user interface for this. And the way it works is it shows total balance, which is all of your ZCash coins that you own. And then available balance is separate, which is all that you would be able to spend if you tried to spend at this moment. Right. So then those funds that are in the middle of being shielded are still in your total balance because they're still yours and they're always going to be yours. But they're not available. Your available balance is a smaller number.
All right. We have something similar, mainly for staking. Yeah, we do something similar. We do something similar for the assets that could get staked. And for us, we kind of do the inverse. Instead of what is available, we say what's locked, although that's kind of a UI UX, 50-50, depending on what people want to see. We might flip it around in the future and say, okay, what's available versus what's locked. But we do something similar. We just haven't exposed that specifically for ZEC, but it's something we aim to do, because I think that is a notable improvement. It's not too hard to do either.
Oh, that's good. We will hopefully end up adding staking to ZCash in the future. So we should learn from the UX around that.
Yeah. And so that's, in a way, what's available is clearly what's not staked in the same sense that for us, it's what's also not yet shielded. It's received, but not yet shielded. Very, very cool. Cool. So that's one of the things we add. I'm trying to see did we miss anything with respect to ZCash? This 2.0 SDK from ECC.
Auto shielding, spend before sync, faster sync.
I think we covered most of it. All I think of as well. And just for all of you developers out there, Edge does build on top of the ECC SDK a React Native library, open source, use it at will, build some cool apps for ZEC. And it was easily our biggest challenge. And for those that, are wondering, what are the challenges in getting privacy coins? It's because there's a lot of native code that is necessary to do optimal, deep level cryptography, which you guys write primarily in Rust. We have to wrap that.
Rust code in there.
A lot of Rust code, which gets wrapped into native iOS and Android, which for us gets wrapped into TypeScript, JavaScript. That's
really cool. I didn't know you open source your React Native library. That could be really useful.
Yeah, the React Native is. Yeah, and I gave a presentation over at ZCon on how to use it. Although the presentation is admittedly a little out of date, because the API to the ECC SDK had changed a bit, and so that probably needs to get updated to show people how they can use that library. And it was very difficult to get it working in React Native due to some incompatibilities with package managers, and I don't want to go down a rabbit hole. But I think there will be the only RN library available, so
so
take advantage of it.
All that work, it'd be really good to let more developers know that it exists and where to get it and how to use it.
Absolutely.
I'm not sure who should do that. Who should there's the Light Client Working Group. It's a group of ZCash wallet developers, basically.
Yeah.
Like you could send someone to show up at our regular light client working group meetings and remind everyone of the existence of your React Native open source library.
Yeah, happy to do so. Definitely want other people on it. Hopefully, even people contributing into it. If they see any issues or features that we didn't support. I know in the 1.0 SDK we had a notable smaller subset of the features of the overall ECC SDK. I think with 2.0 we've covered pretty much the full gamut of features, including specifically in Edge we now have full memo support alongside the 2.0.
Edge used to not do
We
all the
didn't
memos.
do, I think we didn't do detection of memos, although we did sending of the memos. And with the 1.0 SDK, I think there were challenges with the fee. I think we might have had to temporarily remove memo support due to fee estimation being a little bit off when a memo is included. But now with 2.0, seem everything's good, hunky dory, or we're set to go, and other people can go ahead and propose to their loved ones over the ZCash blockchain if they'd really like to, and put little notes on there that only their loved one can see. So I've heard of cool stories of that happening. So that's one little nugget that went into at least Edge, coming out of the 2.0 upgrade, although it wasn't specific to 2.0. But I'd love to kind of finish with the last few minutes we have. Both the questions from the audience, if anyone has any questions or comments, but also kind of roadmap stuff and what is possible. We alluded to it a little bit earlier with the no sync, and I can't remember the exact title of the proposal. And I think it was your brother that had put the proposal out, right? Detection keys. There you go. That was it. Yeah, detection keys. I need to go and dig up that proposal that he had put up and read through it. But you want to give people a little bit of an overview of the concept of detection keys and just give an idea of what at least is cryptographically possible.
Yeah. Real quick, I said that the current ZCash protocol is like state of the art in these trade-offs between privacy and usability. And this new upgrade is further improve the state of the art of usability by eliminating the wait before spending. And then on the privacy side, I'm just trying to figure out how to summarize this. There's basically what users should understand about privacy is like this. And I think it's really useful for security engineers to force themselves to summarize for like a normal user.
Right, of course.
You have to simplify it. Right. And I think that's really important because then you need to simplify your security protocol as well to match the user mental model. So the current mental model that users ought to have is that the server, it's called the Light Wallet D, but it's the Light Wallet server that your wallet connects to.
Or any node. Server, node, anything that's not on your device.
Yes, but there's specifically a server that your wallet, your mobile wallet connects to, which is called the Light Wallet server. And what's a forefront of the state of the art of privacy in ZCash is that server doesn't learn anything about the contents of your transactions. It doesn't learn recipients, amounts, or memos, or anything else. But it does learn the timing of when you send and when you receive transactions. And this is something that security engineers have overthought, and they've overthought. What I'm getting at is
overthought, similar to over-engineered, meaning like they've maybe over-concerned themselves with it.
What I'm getting at is there's a hypothetical possibility that you could keep the Light Wallet D from learning which transactions you receive. Okay? Everyone already knows that the Light Wallet D is going to find out which ciphertext transactions. So nothing about the content of the transactions, but like an encrypted transaction goes by, and the Light Wallet D...
Yeah, the encrypted payload, and it'll know it's yours.
They can't tell anything about it, but they know that you just sent it.
Right.
Because you just uploaded it. You just uploaded a ciphertext to them. They know that means you just sent a transaction. Now, in this trade-off curve between usability and privacy, some security engineers incorrectly think that we can prevent the Light Wallet D server from finding out which encrypted ciphertext or transactions you're downloading. And that can't work in practice for most users because it would require that you don't use memos. And it would use up a lot of bandwidth. All right, so this is a very nuanced argument I'm making here, which a lot of experts might disagree with me. But
it would require a lot of bandwidth because you would have to download every single transaction without the benefit of the compact block.
Well, if you don't want the server, exactly. If you don't want the server to know which ciphertexts are for you, the only way to do that is to download all the ciphertexts.
All of them, correct.
Yeah. So what it boils down to is, in my opinion, as a privacy expert, there's a possible future solution which gives more or less the exact same privacy, but almost completely eliminates the excess bandwidth. And that's this detection keys idea that you have very persuasively argued for it based on your experiences with all of the edge users and the kind of feedback you get from your users.
Absolutely. No question about it. The challenge of synchronization, actually waiting for sync. And I think this even dates back to Bitcoin, where wallets that did have to sync, even though that sync was much faster, right? There's no heavyweight cryptography necessary. Just having to sync to then see your money. And Bitcoin, by and large, didn't have the spend before sync problem. You could always spend before sync, but it did have a sync before receive.
Yeah.
And many of those wallets kind of fell by the wayside because people complained about the user experience so much. So I knew that we needed to solve this in the Zcash realm. And hearing about detection keys as a potential solution, that they were cryptographically possible, made me go, "Oh my God,
yeah,
let's do it. Let's absolutely do it. What do you need in order to make this happen? What analysis do we need to have?" And I know there's some analysis about server computation costs.
Yeah,
there was some concern about that, which hopefully is primarily alleviated, given that our experience and what that cost would likely be versus what people are willing to potentially even pay for. They're like, sure, we'll pay that.
Edge's experience about that is really helpful to help us recognize where the actual sort of engineering bottlenecks are.
Right.
So detection keys, not yet implemented, maybe not widely understood, but on this two-dimensional trade-off of usability and privacy, ZCash currently has the best privacy of any live alternative today, and it has pretty darn good usability, as you can find out if you use Edge today. And the remaining usability problems, like you say, is you have to sync before you can receive your money, and it also means your phone is using up a bunch of bandwidth, which is a bigger issue for some people. Some people have free phone bandwidth, other people don't, right?
Yeah.
And what detection keys offer is basically the exact same privacy. And security experts can quibble with me, and I would be happy to debate and quibble for hours.
Bring it on. Let's do another one about this.
That detection keys have more or less the same privacy, like a little better in some ways, a little worse in some ways, but basically in the same ballpark.
Yep.
But they completely eliminate. Again, this is where making something faster is fine, but making the thing just skip
zero
is really bad.
Exactly.
So detection is very exciting, but not currently available. Future.
How would you describe the detection keys? What exactly is like detection keys as a term might kind of confuse people. We've talked about our grasp, but
that's a great
how
question.
How do they work? Like, what would be the flow of information between a client app like Edge and a server?
Yeah, so it's a new cryptographic key that gets generated by your phone, and whoever you give this key to, they don't gain any insight into anything about you except the ability to detect which encrypted transactions are to you.
Got it. What about from you?
On your phone. It doesn't reveal. The detection key does not reveal which ones are from you. It only reveals which ones are to you.
So interesting. So if it can't tell which ones are from you, since it's a UTXO currency, most transactions from you do return change, which then becomes a to you as well, right? It becomes a to and a from you.
The change comes back in the same transaction.
In the same transaction, which ends up becoming a transaction that is to you as well. as from
That's
you.
a good point. Maybe whoever invents detection keys needs to think this through and see if they can avoid revealing that. You're
Well,
probably
I'm
right.
actually, well, actually, in a way, that's an important piece that I don't know if you want to fix, because when you are syncing, one of the things you want to also know is what transactions came
That's a good
from you.
point.
You want
Yeah,
to know which ones came from you as well. Um, and if someone with the current proposal of detection keys, if I were to send all my money out and not have a change amount come to me, would that fail to be detected by detection keys?
I don't know. It just
Not sure
depends
about that
on
one,
the
huh?
details of how it gets defined
That's it, blended.
cryptographically.
Okay.
But the
Okay.
main point is then your phone doesn't have to download information from the server about anyone
Yeah.
else's transactions.
It's just
So
yours.
now the amount of bandwidth and the delay between you and this and the Light Wallet between your mobile app and the Light Wallet server is the minimal amount. It's just your transactions.
All
And
right.
the privacy cost is that the server gets to find out which transactions are yours, but none of the
Yeah.
contents of it, just the ciphertext. But I would argue that the server already can tell that.
Yeah. From the
So
Light
this
Wallet
isn't
D.
actually a privacy loss. It's
All
just
right.
a UX
It's what we call,
optimization.
it's absolutely best of both worlds in every way, it seems like. And so I can't wait for this. I feel like this is the holy grail
Thanks.
of privacy and UX.
Yeah, your experience with Edge has lots of users and has had for a long time, and so you get lots of user feedback, and you sharing that with the rest of us is really helpful for motivating what we should do next to improve user
If
experience.
anyone's listening and thinks that this is an important piece, feel free to, go ahead and nudge as well. ZCash
Yeah,
forum, right?
yeah,
Obviously, we want
big
people
stuff.
active there, and reach out, let them know. And maybe if you, I'm not sure if there's anyone that can help with and assist in this. What do you think needs to happen for this to come together? That's an important question.
What has to happen? There has to
Yeah.
be someone to do some cryptographic engineering work to define it and analyze it and make sure it's safe.
Hmm.
And then I think it'll have to upgrade the Zcash core protocol, but not in a not too complicated of a way, I think.
Okay. So the core protocol itself needs
Um,
an upgrade. Interesting.
it
Okay.
would probably result in a new address type. I'm not 100% sure, but probably, and that's
But
fine
it'll
because
fit in the U address.
now that we have unified
Right.
addresses, we can go ahead and upgrade the
No,
functionality of our addresses.
would it only support transactions that are created after the implementation of this feature, or
Yeah.
what about the old stuff?
No, only once detection keys were implemented, then new transactions created by wallets that implemented it would be detectable using
Got it.
detection. Yep.
So it would be a pretty long transition where wallets couldn't just stop using these sync style implementations
That's
where
a
you
good
actually do have to
point.
sync.
That's a good point. It
Um,
would be one of those transition periods where we need to wait for everyone else to start sending detectable transactions
yeah.
so that we can
Although
stop syncing the whole chain.
ironically though, if it's a new address format,
Yeah.
one thing that you could do to accelerate that, in Edge, we allow people to create multiple keys,
Hmm.
multiple wallets. You can effectively create a wallet that has this new address format,
Yeah.
doesn't have the old one. It's all
Hmm.
unified anyway.
And that
And
one would
then,
sync differently.
sweep your funds to the
Hmm.
fast sync wallet and just
Yeah.
stop using your slow sync wallet.
Yeah.
And so there's a transition path to help accelerate that effort.
Mhm.
So yeah, so some very fancy cryptography obviously would be necessary. I assume some backend work on Light Wallet D or some equivalent type of a server would be
Hmm.
necessary. You know,
Yeah. The
and then of
cryptography is
course,
not too complicated.
oh, good
But
to
yeah.
hear, because I'm not a cryptographer. I'm just barely an applied cryptography. Just use
Yeah.
the code. You smarter
The
guys, right?
ECC cryptographers had already worked out some of the options for how detection keys could be implemented
Oh,
cryptographically.
cool.
It's probably documented in our GitHub or something.
Got it. Okay. All right. Well, I'll leave it with, I'm very excited. I don't know what it takes to push this forward, or to try to
Yeah.
prioritize it. You let me know, and I will, you know, I'll nudge, or, at least commit time to get it integrated in Edge as
Oh
soon as we
yeah,
have
that
some,
would be.
as soon as we have some SDK that can help us out with that,
Mhm.
we'll commit that. And any
Yeah.
other information that we can provide,
Yeah. That's
that we've
really
already
helpful
gleaned.
offering to do
Cool,
that.
cool.
Yeah. Thanks for that.
Okay.
So before we run out of time, I want
Yeah.
to tell the Zcash community that Edge's support for Zcash is awesome with
Mm.
these upgrades. Like memos are awesome, auto shielding is awesome, unified addresses is awesome, spin before sync is awesome. And I want the ZCash community to know that
Mhm.
ECC's use of the Bootstrap open source license like 2 years ago, and the
Mhm.
ZCash community approving the use of the Bootstrap open source license in ZCash
Mhm.
actually has, through a series of events, led to funding for Edge to be able to do this.
Yep.
So
Exactly. The
I think that's
2.0 upgrade
important.
was a big piece of what we've been doing over the past, gosh, like 6 months to a year, and it
Yeah,
definitely has been assisted by the Bootstrap funding or their kind of
yeah,
combo Zcash ECC Filecoin Grants
yeah.
Foundation. So we
So
very
at the
much thank
time
that
when
effort.
we deployed that, it was controversial. Like, are, are Zcashers actually going to get any benefit from this weird experimental open source license? So I just want Zcashers to know, here's one example. The new version of Edge is way better at Zcash in lots of ways, and that's partly due to that Bootstrap open source license experiment that we started like 2 years ago.
Very cool. Very cool. All right. Definitely let them know that if you appreciate those efforts and are aligned with it, then chime in onto the Zcash forums and let them know.
Yeah.
Very cool. All right.
All right. Thanks so much. It
Well,
was
with
really
that,
fun. Really
yeah, it
appreciate
was.
all the learnings we get from you.
Yeah, and we've appreciated as well. I learned a lot from the privacy community. You're obviously a big piece of that, and the insights that we've had both in these type of conversations and in person. Looking forward to the next time we run into each other. Maybe we can kind of come up with another great
Yeah.
concept or idea to drive Zcash forward. So Zuko, thanks a whole bunch. And if anyone listening, sorry, weren't able to, well, no one really raised their hand, but if you guys do have any questions, you know how to get in contact with us. We're out there
Yeah.
in the Xverse, which I still will call Twitter. So,
Yeah.
and
See you on
enjoy the
Twitter.
rest of the week. Yep. See you as well. Thanks,
Bye.
everyone. Take care. Bye-bye.